So let's go ahead and clear my desk here. Let's go ahead and look at the p-value approach to this question. So we had the 20 pairs of 20 people judging 100 pairs of speakers, and we computed a t-value. We got 9.78. So we're going to use the 9.78 to create a p-value. We know the alternative is greater than. So to get the p-value, you would take the t-distribution, you take the observed value, and then you shade right. So if it's a greater than alternative, you shade right. If it's a less than, you shade left. So we shade right. That's 9.78, like that. So we have tables. So you want to find the area to the right of 9.78. Since degrees of freedom is 19, we look in the 19 row. That's what I was looking for here. So go in row 19 of the tables. I'm there. And you look at the values as you move across. As you go to the right, the tail probability gets smaller and smaller. So if we go to 0.05, it's 1.729. I think that's what we used last time. Yeah, that's what we used last time. If it beats 17.29, it's statistically significant. But we're trying to get the p-value, so we keep going until we find 9.78. Now you might think, if this is anything like z, we're not going to find 9.78 in the tables, so we don't. So go as far as we can. We got 3.883. So the largest t is 3.883. The corresponding tail probability is 0.0005. So if we're out here at, pick a number, 3.883, then you shade right, you get 0.0005. So, but we're not at 3.883. We're out here at 9.78. And then we shade right there. It's going to be a lot less than the 0.005 area to the right, a lot less. So the p-value is less, a lot less than 0.005. And we said before that we're going to use the calculator to get a p-value, but not right now. We said since we're just doing the p-value approach without technology, really, except we did have to compute t, so we had to use the calculator to do that, but we didn't have to do it to do anything else fancy. Since this is less than 0.05, we reject the null hypothesis. Since the p-value is so small, we are very sure the mean is bigger than 50. So the p-value gives you an indication about the strength of evidence. So there's very strong evidence the mean is greater than 50. However, we would like to know, well, if we're so sure it's bigger than 50, about how big do you think it is? So in these cases, it makes sense to construct a confidence interval for mu. Because that'll tell you, well, we're sure it's bigger than 50, but is it like 50.5? Is it 80? What do you think it really is? In what range is it falling? It's clearly bigger than 50, but how much bigger? So here's the confidence interval formula for using t. X bar plus or minus t alpha over 2 s over root n. We're going to use 95% confidence. So at 95% confidence, we're going to use the tail probability is not 5% because you have to divide that 5% by 2. So we take the 5% divided by 2, get 0.25, go down to 19, get 2.093. 2.093, like that. And then we just do x bar plus or minus that times s over root n, and add and subtract the margin of error to x bar. And x bar, I lost x bar. Well, anyway, you get this interval. The low side, the high side. So now we know the true long-term mean seems to be between something like 60 and 65. So on average, you can maybe be 62.5% or 62% average success rate in guessing the height of the taller person just by their voice or their two voices. So there's a p-value approach, and then we're going to go ahead and do a two-sided test, and then we'll go look at our calculator and see what it looks like on the TI calculator. And that'll finish off this section, but we're not done yet.